All right, so 3, 4 is zeros of polynomials, of zeros of polynomial functions. Sorry about that. So another word for zeros, roots, and another word for roots, solutions. So I think I mentioned it before in one of the previous sections, but zeros, roots, and solutions are the same thing. All right. So this section starts off with the rational zero theorem. Wherein you can find all possible rational zeros by doing plus or minus the factors of the constant over the factors of the leading coefficient. And where that comes from is right here, what we haven't read, is that when you go to solve an equation, let's say if I have 2x plus 3 equal to 0 and I solve, I'll subtract 3 from both sides, then divide by 2. This 3 right here is my constant, and this 2x, this 2 is my leading coefficient. So when I actually solve, notice I have the 3, which is my constant, over my leading coefficient. So that's where that comes from. That's the foundation of where that comes from. We're going to have a polynomial, and in order to find the list of all possible solutions, all possible rational solutions, I will take the factors of my constant and place it over the factors of my leading coefficient. All right, so first example or exercise actually asks us to list all possible rational zeros of 15x cubed plus 14x squared minus 3x minus 2. All right, so our leading coefficient is 15 and our constant is 2. And so that's what I wrote right here. Here are my factors of my constant, 1 and 2. Factors of my leading coefficient, which is 15, is 1 times 15 and 3 times 5. So I have 4. So I take each one of these factors and place them over each one of my factors of 15. So I have 1 over 1, 1 over 15, 1 over 3, 1 over 5, 2 over 1, 2 over 15, 2 over 3, and 2 over 5. So now remember, we're listing all possible solutions. And remember, when we look at our leading coefficient, our exponent or leading degree is 3. So we know that we have 3 solutions. So we're talking about all possible solutions. So in here would be at least one of our solutions. So that's all that's stating. And so when you simplify, it's 1 over 15, plus or minus. Don't forget that part as well. That plus or minus is attached to each one. So plus or minus 1, plus or minus 1 over 15, plus or minus 1 over 3, 1 over 5, 2, 2 over 15, 2 over 3, and 2 over 5. All right, questions on that before we do another one? So once again, you find the factors of your constant, place them over each one of your factors of your leading coefficient. All right, next one, 4x to the fifth plus 12x to the fourth minus x minus 6. My constant is 6. Leading coefficient is 4. Factors of my constant, 1, 6, 2, 3. Factors of my leading coefficient, 1 times 4 and 2 and 2. Of course, we only have to use that 2 once. Don't have to write 2 twice. Still gives us the same number if we do so. So I take each one of my factors of my constant and place them over the factors of my leading coefficient. All right, so that's 1 over 1, 1 over 4, 1 over 2, 6 over 1, 6 over 4, 6 over 2. Let me erase this. Then we have 2 over 1, 2 over 4, 2 over 2, 3 over 1, 3 over 4, 3 over 2. Now you do want to simplify your list. 1 over 1 is 1. 1 over 4 is fine. 1 over 2, 6. 6 over 4 reduces to, oh, I'm going to erase it back. 6 over 4 reduces to 3 over 2. And then 6 over 2, of course, reduces to 3. Then we have 2. And 2 over 4 reduces to 1/2. So we don't need that. 2 over 2 is 1. We don't need that. 3 over 1 is 3. We already have that here. 3 over 4 we can use, and then 3 over 2 we already have here. So you don't need to write any repeated solutions. All right, questions, any questions? All right. All right, so if they give you an exercise that says find all zeros, got f of x is equal to x cubed plus 7x squared plus 11x minus 3. So we can find all possible zeros first by performing the exercise we just performed, where we find our constant, which is 3, and place them over the factors of our leading coefficient. So our constant is 3, leading coefficient is 1. So we just place 1 over 1 and then 3 over 1. So we didn't have that many. Had a short list this time. And so here are our possible zeros. So don't forget, going back here, at the most we can have is 3 solutions. Now it is possible to have 1 real and 2 imaginary or something like that. So we do need to check. We can't just assume that because we have 3 here that all 3 of these are solutions. And I mean 4. We got 4 right here. I said 3, but that plus or minus is assigned to this 3 as well. So we have 4 possible. Matter of fact, we use. All right. So we use synthetic division to see which is a solution. Once again, options 1, -1, 3, -3. And remember, we did a synthetic division process, so I'll do that again. Let me erase this stuff. So if we decide to use 1 first to check. Now we're going to use our coefficients. Remember, if you go back, we have 1, 7, 11, and -3. So that's where that came from. So 1, 7, 11, and -3. So we're going to use 1 first. That's what we're putting right here. First part of your synthetic division is bring down 1. So that's what we did. And now 1 times 1 will give you 1. 1 plus 7 is 8. Then you would do 1 times 8, which will give you 8. 1 times 8, I mean not 1 times 8, 11 plus 8 will be 19. Then 1 times 19 is 19. -3 plus 19 is 16. So this means that 1 is not a solution, because if it was, then it would be a 0 right here. So you would try the next one on the list, which is -1. So that's why we have -1 right here. Going through the same process, -1 times 1 is -1. 7 plus -1 is 6. -1 times 6 is -6. 11 plus -6 is 5. -1 times 5 is -5. And then that'll put us -8 right here. Once again, the reason why it's called a 0 is because you need a 0 right here if it's a solution. So do the same process for 3. That one doesn't work. But we see on that last one, -3 ends up giving us a solution. Ends up giving us 0 as a remainder, which means it is a solution. So I'll give you a chance to copy that before we finish it off. All right, any questions? Once again, just perform a synthetic division in order to figure out which one of those would be a solution. Now, this process, unless they give you a hint, can be a little time consuming. You know, if you imagine having 10 possible solutions and you get all the way down to 10, but, you know, sometimes that is the process that you have. All right, so we have one solution. Remember, we're supposed to have 3. We just found out that -3 is a solution. And so remember, we use this to break down the function. So what's left is x squared plus 4x minus 1. Remember, we start off with one exponent less than what we had originally. Remember, we started off with x cubed. So now here we at x squared. So 1x squared plus 4x minus 1. So can I factor that? So we use the quadratic formula. If I went up too far, please let me know if you're still trying to copy. So A is 1, B is 4, C is -1, Plug them into the quadratic formula accordingly. That'll be -4 plus or minus 4 squared minus 4 times -1 over 2 times 1. That simplifies to 16 plus 4 under the radical, which is 20. You can break down that 20 by doing the square root of 4 times 5, taking the square root of 4, which is 2 square root of 5. And then here, that 2 in the denominator can divide into each numerator, leaving you with -2, plus or minus square root of 5. And you see right here in the purple, we list all 3 of our solutions. All right, questions? Any questions? Make sure we're all right. Now scroll up. All right. So next thing is the complex conjugate theorem. Just says that if a plus bi is a solution of f of x, then that means a minus bi is also a solution of the function. So here, just examples in the red, just examples of complex conjugates. Just a reminder, 4 plus 5i, the complex conjugate of that is 4 minus 5i. Only thing that we change is the sign of the imaginary part. -2 plus 7i, complex conjugate would be -2 minus 7i. And even -8i, complex conjugate would be +8i. Once again, all we change is the sign of the imaginary part. All right, so next example or next exercise, find a 4th degree polynomial function with real coefficients that has -2, 2, I as zeros and such that f of 3 is equal to -150. So in other words, when you plug 3 into the function, is equal to -150. All right. So let me put my red comments back. So a few things that I pointed out. All right. We can go back here. Okay. Sorry about that. All right, so a few things I want to point out. So 4th degree means that there's 4 solutions. Highest degree of x is going to be 4. They give you 3 solutions already. All right, so they give you -2, 2, and I. And when you plug in 3 into this function, the result is -150. So they give the solutions. They give you the solutions and they want to know what function is produced or what function will produce the solutions. Let me check one thing. All right, good. So we want to find a polynomial function that has the highest exponent on a variable as 4 and has these three solutions. So they give us -2 and they give us +2, which is fine. Now they give us I, but because they give us I, that means they also give us the fourth solution, which is -I. That occurs because of the complex conjugate theorem. All right, so we have our 4 solutions. All right, so now we're going to work in reverse. We have our solutions, but we want to know what polynomial gives us these solutions. So now in order for x equal to -2 to occur, if you do that in reverse, I had to have this situation, x plus 2 equal to 0. Remember what happens when we go about solving our polynomials? We break them down into our parentheses, and then we'll set each parentheses equal to 0. Well, in order for x equal to -2 to be one of my solutions, then in one of my parentheses, I had to have x equal to 2. So when I set it equal to 0, I subtract 2 from both sides, and I have x equal to -2. So we're going to do the opposite of each one of our solutions. So notice what we did right here, x minus -2, x minus 2, x minus I, and x minus -I. So that's how you would go about setting that up. All right, and then that'll leave you with x plus 2, x minus 2, x minus I, and x plus I. Any problem with that? All right, so we're going to FOIL out these two and FOIL out these two, multiply those out. That would be the easiest way to take care of that versus doing them in any type of different order. So x plus 2, I didn't mean to do it that way. Get that back. All right, so we're going to FOIL that out, x plus 2 times x minus 2, and then x minus I times x plus I. And that will give us x squared minus 2x plus 2x minus 4, x squared minus ix minus ix minus I squared. And so this is why we go ahead and multiply those quantities together, because we'll see that 2x's cancel in the middle here, ix cancel in the middle here. Don't forget I squared is -1. So we have x squared minus 4, a squared minus -1. Oh, also I forgot to mention that we put an a out front initially because we don't know if we're going to have something out front or not. So we'll talk about that in a second. But I forgot to mention that we always put an a in the front to represent a possible constant that's sitting in front of our function. All right. So reduce that or simplify that. That'll be x squared plus 1. And then we'll FOIL that out. X squared times x squared is x to the 4th. X squared times 1 is 1x squared, -4x squared. Then -4 times 1 is -4. Combine your like terms. We now have a times x to the 4th minus 3x squared minus 4. Any questions? Should be all right. All right, last thing. So remember we had that initial condition, f of 3 is equal to negative 150. So when I plug 3 into the function, I'm supposed to get out negative 150. And that's where a may come into play. So we'll just see. So what we have to do is plug in 3 into the function. We're talking about this function right here. So that's why we have 3 to the 4th minus 3 times 3 squared minus 4. And once again, it's supposed to be equal to 150, negative 150. Simplify, 3 to the 4th is 81. 3 squared is 9. So it's 81 minus 27 minus 4 because 3 times 9. That reduces to 50. 58 equal to negative 150. Divide by 50. And a is equal to negative 3. Make sure we are okay. All right, so a is equal to negative 3, so we can plug that in right here in front of our function. Distribute that, and that gives us our 4th degree equation or 4th degree function that produces those 4 solutions. And when I plug in 3, I will get out negative 150. So that's what this function is for us. All right. All right, any questions? Any questions? Okay, so like I mentioned, I do have that conflict, and so this would be a good place to stop. Next class we'll run it full, but before we dismiss, any questions? Any questions? Everybody good? Everybody straight?
I have a quick question. So that answer that we got, if they ask us, that's what we're supposed to type in?
Yep, that's it right there. Yep.
Thank you.
All right. Okay, so if everybody's good, then I'm good. I will see you guys on next class. See you guys on Wednesday. And if you have any questions, don't hesitate to shoot me that email. You guys have a good one.